Hello, everybody. Good morning, good afternoon, good very late evening when I see this correctly here where you're from. So thank you for joining today's webinar here with the OpenADR Alliance. We're just going to give it 1 or 2 more minutes as I'm seeing people popping in consistently here. So bear with us for just a second. Evan, if you could maybe mute for now. Perfect. Thanks. All right, excellent. So I see good number of people already on. We'll certainly get some more, but I would say let's get started here so we're not wasting anybody's time. And I'm gonna hop right in here into the housekeeping items for today. If you have attended one of our previous webinars, you will know that the webinar is being recorded, and the slide decks as well as the recording will be available on our website. You will also find it in the follow-up email, which goes out pretty exactly 24 hours after the webinar today. So you will have the link in there also. But of course, it's also accessible through our website. In the quick links on the right, you can see the webinar series as well. All the attendees are in listen-only mode. Over time, it became clear that otherwise this is not really working. So we do need you to ask questions in the questions tab. So if you look at your GoToWebinar, the little application window, there will be a questions box. You can go in there and type your questions. We do want to hold them until the end. So we're not going to answer questions between the presentations, but rather at the end. So please feel free to type them as we are going through the slides and our presenters today, and we will go through as many questions as we can at the end of today. So our 2 speakers today will be Marina Hott from Vivo Energy. And Marina is the Managing Director in the Americas. It's great to have you on today, Marina. And Marina is leading Vivo's Energy and Vivo Energy's EV charging optimization business in North America, and has really a lot of experience, already 2 decades in the power sector, with a lot of knowledge here on all sides. You know, when I read that, it's great to have you, Marina. And we have Evan Kirchhoff on. I hope I said that German enough. I can probably say that even more German. Kirchhoff, who is the CEO and co-founder of Open Road Technologies. And he is also a 20-year veteran with all kinds of software and hardware technology companies, has worked for Adobe, Razer, Google, and that's really great to have you here as well. Of course, the theme today is EVs, EV charging, managed charging, electric vehicles in general. And we kind of determined that even though your companies are in a similar space, you're not too competitive. There's, of course, I'm sure there's always overlap, but interesting new problems to solve here. But to give you a little intro of that, I'm gonna quickly introduce what OpenADR really is to those of you on the line that have not heard of it, which is probably unlikely, but still. OpenADR is a communication protocol between a demand response, a service provider, as we used to call it. I mean, now it can be all all kinds of functions. It can be a DER, a management system, a DERMS sitting at the utility. It can be a bigger aggregator, whatever you have that is managing demand side systems. And we communicate them over the internet to the demand side mechanisms there, to the resources that are out in the field. So as you can see here, it's pretty straightforward, usually just through the internet, either directly to buildings, to control systems like charge point operators and so on and so forth. And our signals range from prices all the way to specific energy requirements that are out there. And so where are we? The Alliance is a non-profit organization incorporated in California, where OpenADR originated over 20 years ago. And the two specifications that we have are already in place, 2.0A and 2.0B, are now over 11 and 12 years old. And we are just, or we're just not really working on, but we have finished actually 3.0, are finalizing the certification program, and that will come out here in just a few days. To give you an idea of how important EV charging and management thereof is, I just took a few snapshots here from our product listing page. And of course, this is way too small for you to read, but the idea is just to show you how many there are. This was simply a search for the keyword charging in our product database. So if you go to products.openadr.org or openadr.org and then click on the products, certified products, you can play around there. You can put in EV, you can put in charging and other things, and there will be a slightly different list popping up for all of these search terms. But just simply, if you put in charging, these are all the charge management systems that are already OpenADR certified. So it's quite a big percentage of our membership. So it's really an important topic. And maybe just real quick, because I see that there's a lot of people also from all over the world, not just from the US, of course, participating here. So maybe just looking at our very basic use cases. For commercial charging, we have seen this type of use case now since several years already. So we have OpenADR to a charge point operator, which then in turn manages the chargers out there. And often, not in most cases, I would say, it's OCPP then down to the charge point, really. Because OCPP, of course, has different functionalities, account management, credit card processing, things like that. So this is the typical use case there. What we have seen now in the last few years popping up is essentially a slightly different connection here, even though we're doing the same thing, but in a residential space in particular, the car makers, the car OEMs have inserted themselves in the communication here. So in quite a few cases now, OpenADR is received by the car manufacturer and their telemetry system, and the charge management control signals are then being sent through the car telemetry to modify charging times, strength, and things like that. So there's a bit of a facilitation here in place between the car manufacturers and the utility. And last but not least, something that includes, of course, also electric vehicle is the virtual power plant. Many people are talking about that. There's different definitions, but for me, it's simply any kind of connection between different consumers of energies, resources of energies, and so on and so forth. And EVs are, of course, playing a big role in here as well. So that being said, I'm happy to pass it on now to our presenters today. We decided that Marina is gonna go first. So Marina, I'm gonna go ahead and make you the presenter here. Okay, you should have it. Perfect. We see your slides.
Okay, wonderful. And can you hear me as well?
Excellent. Yes, go right ahead.
Wonderful. Well, thank you, Rolf, and the OpenADR Alliance for hosting this event and for having me here. I'm really glad to be here. Hello, everyone. Marina Hod. I lead Wevo Energy's business in North America, and so I'll just start by telling you a little bit about Wevo Energy, who we are, and what we do. Wevo Energy was founded in 2021 with a vision of electrifying every parking space, enabling dense parking lots and garages to have as many EV chargers as possible given the electrical capacity constraints at a given site. Our load management solution maximizes existing building infrastructure by intelligently allocating power where and when it's needed most, allowing sites to get more electric vehicles charged without expensive infrastructure upgrades. Our smart algorithms learn drivers' behavior and create an optimal charging schedule, charging when rates are lowest and ensuring that the vehicle is fully charged by the time that it's actually needed by the driver. And you'll hear more about the implications of this shortly. But today, we operate across 8 countries, managing EV charging at over 1,200 sites. That represents the electrification of over 150,000 parking spaces, many of which are actually at apartment complexes. We announced earlier this year that we've been acquired by SolarEdge. For those who are not familiar, SolarEdge is a global leader in solar inverters and optimizers, which basically allows us to do even more with EV charging optimization with other distributed energy resources like solar and storage. Last thing I'll mention is that we are very much about open standards. We are fully OCPP certified for 1.6 and 2.0.1 for both the protocol and security. And so we'll work with any standard EV charger that's OCPP compliant. So in terms of what we're seeing in the EV space, and certainly, you know, in North America, but I think this trend applies beyond North America as well, is really aggressive adoption of electric vehicles. By 2030, more than half of all new vehicle sales are going to be electric vehicles, and a lot of the charging is, well, most of the charging actually is done at home, right? It's not at the side of the highway, it's not next to a grocery store, but it's actually the places where people live. And for that, as adoption grows, we really need to have more novel approaches for constrained environments that really, you know, the amount of demand that's going to arise from all of this transportation electrification is going to be unprecedented for our grid. And from a site host's perspective, a lot of times when people are considering EV charging projects at their site, they're really thinking about CapEx, right? They're thinking about the physical installation work that's going to be required, trenching and so on, and they're thinking about purchasing the hardware itself, but they're not necessarily thinking about OpEx, right? The ongoing operation of the EV charging, which is actually just as important, if not more important than the installation itself. Because effectively the way in which you're going to be using those chargers at the site, the habits, the way in which that charging is going to happen can really have a significant impact on the CapEx and the earlier stages of the project as well. So really these things need to go hand in hand. And it's also worth mentioning here that there are a number of challenges related to EV charging that really need to be considered before a single contract is signed, before a single shovel hits the ground. And it's not always obvious how these challenges can be overcome through OpEx rather than CapEx solutions, but I'll tell you more about that in a moment. So first, what are these challenges? I'll try to go through them pretty quick. Ownership, right? So this is really about who owns the parking spot and who's making decisions about electrifying that parking spot, right? So is it the landlord? Is it a deeded parking space owner? who's actually going to be spending the money to electrify that parking space and then handle the burden of the ongoing costs and maintenance and so on related to that EV charger. The next one is infrastructure. Oftentimes we're dealing with older building stock. These buildings were never intended, right? They were never built with the intent that you're going to have to get power out to the parking spots, and that you're going to have communications available, some kind of connectivity to actually be able to have EV charging there. Power and energy is probably the one that we hear most about, right? Because having to ask the utility for a service upgrade, this could be cost prohibitive and kill the whole project, frankly. Or it could just take a really long time. Sometimes years is not uncommon. And finally, billing. Time and time again, this is identified as a major pain point when it comes to EV charging. No landlord wants to have to chase their tenant to pay for EV charging. Certainly no employer wants to have to chase their employee, right? And so this is a broader sort of topic of user experience, right? It just has to be easy, transparent, and simple. And as I mentioned, power constraints, I think this is maybe most relevant for the audience here today. This is one of the biggest barriers for EV charging projects. And so with limited power availability, can be very costly for expansion and really needs to be properly addressed. But power constraints can actually become power possibility with the right solution for EV charging. Solutions that would allow the site host to maximize the number of chargers installed, minimize infrastructure costs, and create a pathway for buildings to scale their EV charging as more residents and employees start to drive EVs. So quick caveat here, I'm not an engineer, but I know enough to be dangerous. Okay, so let me just talk you through a little bit about how this could work. What I have up here is, a kind of typical example of how EV charging projects often get done. I have a 250 amp panel, 550 amp circuits. Every charger is getting their own cable run. This is a lot of cable. It's very expensive. It's not very easy to scale. And so what we propose is a string installation methodology where now in this example, I have an 80 amp panel. I'm pulling a thicker cable across and then I'm daisy chaining the chargers as we go. This is a lot less cable. It's a lot cheaper to do this installation. It's also a lot easier to add more chargers to the string as you go. But if you're doing the math and you're thinking, wait a minute, if each of those chargers is 32 amps and your panel only has 80 amps, what's going to happen when there are vehicles, at each of these bays trying to charge, right? Aren't you going to trip the breaker? And in fact, no, because this is where the OpEx piece comes in, because you can have a software solution that's going to protect the string from overcurrent. And really, when I talk about EV charging optimization, that's ultimately what I'm talking about. I'm talking about optimizing EV charging across multiple parameters, including the physical constraints of the hierarchy. So basically understanding the constraints at the mains, every panel, sub-panel, and so on. And then additional elements like learning driver behavior and also optimizing for price. Right, so how does this actually work? Do drivers need to overcomplicate their lives by constantly plugging in and out and changing settings? No, of course not, right? If designed correctly, then all of this load balancing should happen automatically as it does in our system. And to illustrate that, it can look something like this. So in this example, we have a 32 amp panel. The first vehicle is plugged in and it's charging at 16 amps. And you can see in the top right-hand corner here what that actually looks like from a system perspective. Okay, one car, everything is great. Now a second car plugs in. Now you have two vehicles charging at 16 amps. Okay, that's the limit, that 32 amps, right? And you can see what that's looking like at the top as well. So now, what's going to happen when a third vehicle plugs in? Is it going to trip the breaker? No, of course not. The system is smart enough to know better. So when the third vehicle plugs in, the first thing that happens is that the system makes room for that vehicle by tuning down how much charge the other vehicles are getting. And only then, once it's made room for that third vehicle, it can start to charge that third vehicle as well. Now, you might notice that the power is not being distributed evenly, right? It's not a linear distribution. Why is that? Because the system is smarter than that, and it takes other things into consideration, not just a first come, first serve basis, but it actually takes a lot of other inputs into account to figure out how to best allocate the power available across the vehicles that are plugged in. Okay, so at this point, you might be thinking, this is nice, but what if the driver doesn't want to get only 10 out of 16 amps? What if they want more juice? And so that's where the boost capability comes in. So we have the only system that actually allows drivers to override default settings, whether they're getting less capacity from a load balancing perspective, or because the system automatically defaults their charging to off-peak times. The driver can override the default settings and get as much capacity as their vehicle will take at that moment in time. But of course, they pay a premium for that, right? So this is something that people really love because it gives them the ability to still be in control and override default settings if they choose. The other thing I wanted to touch on briefly is, as we're talking about energy management and load management, is to describe a little bit about static and dynamic load balancing, right? So when we talk about static load balancing, this really assumes a fixed or static amount of electricity that's available to all EV chargers at the site. This amount is then effectively distributed across all the chargers that have a vehicle plugged in. So as an example, if a building has a 200 amp connection where 50 amps is used for LED lighting, you can allocate the remaining 150 amps to EV charging, given that LED lighting load is low and predictable. But dynamic load balancing involves basically adding a meter to the system where you can have a constant measurement of non-EV loads, and that allows you to calculate the load that's available for EV usage at any given point in time. So as an example, if you consider a building with a 200 amp connection shared between EVs and the building's, say, water pump rated at 100 amps, the water is pumped to the rooftop tank only a few times a day, right? So you don't need to reserve that 100 amps all the time. When the pump is off, that capacity is available for EV charging at the site. Very quickly, I wanted to highlight the importance of default settings, right? So there are really significant implications for the grid, not only from the standpoint of making sure that there are the right incentives available for on-peak and off-peak times, but also your default settings. And so what we have found in real data from having our system live across so many sites and thousands and thousands of EV chargers, dozens of thousands of transactions that have been processed, is that people will rarely override default settings. And so if we can make sure that the default settings are set correctly to really benefit the grid, so that, as an example, that charging defaults to off-peak times, people very rarely override that. However, if those default settings aren't in place and you do it the other way, the default is that people start charging their vehicle as soon as they plug in, but they have the ability to override to off-peak times if they want. That can have very significant implications for the grid. Okay, so when we talk about optimizing EV charging and making most efficient use of available infrastructure capacity, what are we really talking about? Ultimately, we want to make sure that EV charging is a win-win-win for the driver, for the site owner, for our grid, and for our society as a whole. So to sum it up, first for the driver, right? Most people drive on average maybe 30 miles a day, okay? And most EVs out there today have a range of well over 250 miles, right? So actually, they don't need to charge all the time. Most people charge a few times a week. And so there's no reason why EVs should be plugged in all the time. You want to make sure that it's something that works for the driver, and they're going to be able to charge at the lowest cost possible with the highest level of convenience. Next is pricing. Economic incentives are really important for driving the kind of behavior that you want. You want people to charge during off-peak times, so then you need to have a significant differential between on-peak and off-peak times. And of course, having the right default settings, as I mentioned. Ease of use and usability is a really key one, right? Those settings are important. Make it easy for people to do the thing that you want them to do. If it's hard but the right thing, they're going to be far less likely to do it. Grid status. If it's a very hot day when the system operator is already struggling to bring enough supply to meet demand, the last thing that they need is additional EV charging, right? And so there is, of course, a hierarchy. There are lots of things that we can do very easily, respond to time of use tariffs, but certainly demand response programs and those kinds of things can be very easy to implement for EV charging. And finally, clean energy, right? Wouldn't it be great to do as much charging as possible when the wind is blowing or when the sun is shining? This is all part of managing and optimizing your EV charging, and we already have capabilities within the system that allow site hosts to co-optimize solar at their site directly with EV charging at their site. So finally, I'll just leave it here because I don't expect anyone to do this for altruistic reasons. Optimizing EV charging in the way that I've described is just good business sense, right? Because ultimately, if you take advantage of all of these things, you can be reducing the total cost of ownership by up to 50% over a 5-year period. So would love to have a deeper discussion about optimizing EV charging and how Wevo can help. From here, I guess I will wrap it up and pass it on to our next speaker.
Excellent. Great insights here, Marina. Thank you very much. And then, like we said, we have a few questions already collected here, but we will do that at the end. So Evan, I'm gonna swing the presentation mode over to you. So you should see it now.
Okay. Yeah, can people hear me and see my screen?
Yep, perfect. There we go. Full screen there.
Okay. Yeah. Hello, everyone. I'm the co-founder of Open Road Technologies. My co-founder Sean is also here in the audience. We're an earlier stage startup. We're prototype stage, and I'll talk about that in a bit. But what we're building is the world's first portable, true level 3 fast charging platform. And this actually hits a couple of different clusters of pain points around electrification. So EV adoption has a few issues, and on one side, the drivers have issues around range anxiety, of course, but also a lot of stuff around access to charging, especially access to fast charging, where they want it when it's not too busy, or in areas that are basically fast charging deserts right now, and there's no equitable access. On the grid side, though, obviously, the presence of a lot of EVs and new electrical vehicles and electrical loads places a lot of strains in the grid. At the same time, part of this energy transition is removing a lot of energy from fossil to renewables, which have their own pain points. I mean, you get solar surges in the afternoon, you get wind surges at night. Base load is all different now. So there's a lot of, there's two challenges that are basically, we think, the same challenge in a way, and we're trying to solve things at the intersection of these two problems. So the EV charging market, kind of at a high level, looks like this. There's a lot of consumer stuff for use in the home in the bottom left there, the level 1, level 2 stuff. There's a lot of level 3 stuff that's very high end by the highway. And there's also sort of a lot of battery products mixed into all of this, but they're not really charging products per se. So we think there's a big gap in the market to bring fast charging down to sort of cheaper, smaller, lower footprint, lower price points. And there's sort of nothing in that space right now. So this is the vision of what we're building here. This is a modular high-speed battery system, smart battery system, stackable for different levels of configuration, different levels of power capacity, and also power delivery. So we get our smart batteries. We got high-speed DC charging integrated into the top part there. And we have a cloud software platform that ties it all together and allows us to both manage these things and also use these things as virtual power plants. This is the industrial form factor we're kind of looking at right now. It's about 18 by 18 inches square, 8 inches high. It's about this big, small footprint. These blocks weigh about 50 pounds, which is chosen deliberately. Each one has about 3.5 kilowatt hours of capacity and 25 kilowatts of power output, which is pretty fast. but you can stack up to 6 and it adds linearly until you get to 150 kilowatt hours, or sorry, 150 kilowatts at 20 kilowatt hours of capacity. Now, why put batteries in a charger? In software terms and software metaphors, there's kind of a few advantages here. One is you get buffering. You get to take sort of standard level 1, level 2 outlets or circuitry, buffer power slowly input, whatever the speed you can get out of the wall socket or the installed circuit, and then burst quickly into the car on output. So input is AC, there's an inverter. We cache the power, or we buffer the power, and then we can go into the car at whatever speed we can get out of the battery, which is, again, up to 150 kilowatts, and this is just DC charging at that point. Because it's a battery, you also now have another cache. So currently you can cache power in vehicles, you can do V2G, but there's no third location where you can store it in between. So if the vehicle's not there, it's not on the grid. Now we have an intermediate location to store energy and even transport energy around in a portable form factor, separate from the vehicle, or in fact, even inside the vehicle if you want to. And then finally, time shifting is important, both because you want to do cost optimization around time of use, but also we want to shift energy from either high grid load times or high load times on the local site to times when there's less load and less demand. So because it's going to be very hard to build out the power grid all at the same time everywhere to high speed charging, we want to be able to make better use of the existing infrastructure, both the grid itself and also on site locations. And so in a way, we're kind of complementary to Wevo, and we're solving the same problem in a different way. And you can imagine both of these solutions being installed in the same location, actually. So because these are portable modules, you can put 1 or 2 in your trunk. These 2 modules would get you about 28 miles of range in the average kind of consumer Tesla in about 8 minutes of charge time. So the idea is if you wanted to have sort of backup power on the road or backup power for utility fleets, you could transport these things around in modular fashion. We also believe there's military applications. There's a lot of initiatives, obviously, in the military around electrification of all kinds of vehicles, small vehicles, large vehicles, and drones. And we hope to eventually hit this market as well. And that's one of the reasons we've gone to this particular modular weight is there's kind of a military guideline around 50 pounds, it's sort of an OSHA thing. It's probably not a hard and fast exactly 50, but there's a general rule of thumb in OSHA that once you get above this, it's a different category of operation. So this is sort of the sweet spot for getting a decent amount of power in a box, but also getting decent portability of the system. Now, of course, if you put these things outside by the road, we do an enclosure like this, and properly weatherproof with a payment interface for monetization. So this is how you build a really kind of still very low end compared to the market now, low footprint, but high speed charger. So we want to be able to tuck these things into kind of anywhere, like gas stations, convenience stores, just small retail locations that have relatively conventional circuitry, not a ton of excess power, could use this caching functionality to basically build up high-speed charging in a really kind of small footprint, and hopefully with minimal or zero trenching. I mean, we want to really minimize install costs, because one of the pain points about getting a nationwide charging network out there and the kind of long tail of these remote locations has been just the install cost. So we want to minimize all of those things that are kind of seem like secondary considerations, but they're actually pretty primary. So this is what we're trying to do as a nation right now. The reason we've picked 150 kilowatts as our top configuration is that meets the low end configuration for what the federal government considers high-speed DC charging, especially with this alternative fuel corridor program under NEVI. So there's a huge amount of money right now that is basically available for building out this network, and we've sort of gotten as far as the solid lines on the map, and the dotted lines are troublesome. I mean, people think this program is way behind schedule, it's going slowly, but it's really actually a hard problem to get these things out there. So we're hoping to address a lot of this, or at least a lot of these locations, by being able to run on whatever power is currently on site. I mean, it could technically be 120 volts, ideally 30 amp, 50 amp, and put high-speed charging in a lot of long tail locations that are just not going to have a high-speed grid anytime soon. So because we're both a charger and a battery, we integrate to 2 different software stacks. And so on the charger management side, we do OCPP. I should say will. You can't buy this product yet. This is prototype. We'll integrate OCPP, and on the VPP side, we can serve as a virtual power plant, and we'll integrate, of course, to OpenADR. So there's sort of there's a couple of overlapping markets here, but we think a lot of people seem interested in getting both at once. The functionality of the dispersed battery network as a virtual power plant, dispersed energy system, and also in charging. So to the extent that people want both of these things in the same location, that's kind of our Venn diagram overlap. We're looking at these target markets. They're all B2B markets. I mean, first of all, obviously EV fleet operators. I mean, we come out of light electric vehicle companies, me and my co-founder, so we have experience talking fleet operators. We also think, like I said, there's a market for commercial chargers in these long tail locations. But also what we've discovered, and we're actually talking to a power utility right now in Texas, there's a third market where utilities now are wanting to co-locate battery networks on, in many cases, on customer sites behind the meter. This is actually happening in Cupertino and Sunnyvale, where I am right now. PG&E is actually doing this. They're installing a lot of batteries all over the place, and the Powerwalls seems like the dominant player right now. And, you know, it's a good product. So what we offer sort of in that space is the battery co-location plus the ability to fast charge cars. So some utilities, especially in rural areas, seem to have dual mandates, of course, to do both of these things at once. And so it's the solving two problems at once. It's kind of our value proposition here. So we're an American product, an American company. Our engineers, our hardware engineers are in Michigan. Software team is here. Now, of course, Made in USA means a bunch of different things to people. So you might do this for a few different reasons. You might be avoiding tariffs. You might be avoiding supply chain risk, we saw during COVID. In many cases, you're just avoiding China. So allied countries are okay. The NAFTA zone is fine. You know, Korean batteries are okay. So we're prepared to do a lot of different flavors of Made in USA. And obviously for military purposes, you've got specific sanctioned companies in China you just can't buy from at all for part supply. But also for federal subsidy purposes, battery cells made in the USA, like factories in Arizona, are especially favored. And so we'll probably end up with different SKUs depending on the market. But broadly speaking, we're, at least so far, we're avoiding any critical Chinese parts just because it's sort of the first step. And we'll just be American as people need us to be. So where are we actually at? You can't buy this, I can't give you a price. What we're at right now is we're prototyping the thing on the left, which is a self-contained proof of concept that's a 7 kilowatt hour suitcase that charges 50 kilowatts out. This is basically de-risking the science because we're then raising money based on that, and this will, this in a lot of people's minds will prove that we can build this product. I mean, we know we can, but this is a proof of concept. Following that, we're planning to build the second prototype and take that design to market, which is the modular prototype. Now, there's more challenges there, obviously, around interconnection and you know, just mechanical fabrication, a bunch of other stuff. And so it's less, you know, core science work than the thing on the left. But once we get the second prototype done and we have what I call a release candidate, which means something we can start taking to certification, something we can start pre-selling, that's the point at which we'll probably start talking more about, you know, what is our price. And we're hoping to get to that optimistically end of this year. I mean, give or take, but this is not too far off because we're solving a lot of the problems on the right in the unit on the left, just in a less glamorous enclosure. So where are we at right now on the technology readiness scale is a TRL4, which means the stuff works in the lab on a bench. The next step is to finish the enclosed prototype and be able to take it out in the field and just charge cars under field conditions, which is TRL5. So we feel our core technology is validated, but we have to do a lot of the other work around productizing this thing, getting it closer and closer to a mass manufacturing product that we can start sort of pre-selling to people. This is some illustrations of the team in Michigan. The thing on the bottom right is actually a 20 kilowatt load bank. So you can see how it heats up with a heat gun. The bottom left thing is a circuit board we're not using anymore, but it was very exciting while it lasted. So we've gone through some iterations on this thing. So we're pretty confident that we can now get to a prototype in a reasonable time. And that's essentially where we're at. Now, the reason why we're talking about this, because we're still pretty stealthy, there's no real web presence besides one page. There's not much going on LinkedIn. We do want to start talking to more utilities around sort of product requirements in that second prototype, because we have a high level sense of how to interconnect to the software protocols, and you know, it has to be waterproof in certs ways. There's some UL certs we're pretty sure we have to have, but if there are other requirements that would make this more viable and more appealing as a VPP platform, this is the time we want to start learning about that. So like I said, we're engaging one utility now. We'd love to make more utility friends. So yeah, we'd love to talk more about sort of that market for this product. And thank you.
Excellent, excellent. Thanks, Evan. That's yeah, definitely something interesting. There's a number of questions here, and I have a couple myself. So let's see here. Let's swing back so people see our contact. I gotta quickly move things. All right, so should be seeing this here. Just to double check, Evan, you see my slide, right, with our contact?
I do see your slide, yeah.
Okay, perfect. Yeah, because I have too many screens here. All right, very good. So thank you so much, both of you. Very different things here to take into account. So as we discussed before, it's not too much overlap, so that's great. Couple of questions here. A few administrative ones I already answered directly to the people. So one question from Stephen is, how many utilities in Europe and in the UK are adopting the OpenADR standard? So I'm gonna hop in on that, of course. A little tricky for us to really have an exact number there. But if we talk about US, of course, it's pretty broadly used, coming out of California, all of the California IOUs, and Hawaii, and then in the other direction also a lot. We are aware of over 130 or so programs that use OpenADR, and then the other direction, Japan and Korea have been using it also since many years, and more recently New Zealand is using it and have also started new trials with that. Now, to your question, Europe and the UK, it's a different story. I think in Europe, what we have observed, and feel free to always start a conversation with us because we want to learn more about that also, is that demand response flexibility all the way to the customer equipment is not done very much yet. We do know of smaller deployments since a couple of years already in France. I believe ABB in Italy was doing something, not a utility, of course, but they were working on something there with the utility. And we do see now quite a few new projects popping up in the Netherlands, in the UK. In the UK, a number of the big network operators are looking at it. But I'm not aware that there are already larger scale programs up and running. So we are hoping that this will come very soon when these initial trials are done. And hopefully that helps a little bit. Another question here from Stephen. I think this was Marina, this was during your presentation. And I think it might have been clarified in follow-up slides, but the question is, does the US electrical code allow for daisy chaining? And he understands that the software is there to ensure load balancing, but does not exceed the circuit rating. But from a normative standpoint, I think it's not allowed. So I'm not sure. I think the sketch you showed, Marina, is really more the control interface, not necessarily the electrical interface, right?
Yeah, so look, I appreciate the question. This is why I always caveat that slide by saying I'm not an engineer, but I know enough to be dangerous. We are a software company. We show ways in which the EV charging can be managed. We work with installers, electricians, charge point operators, EV charging service providers across the country, across the continent, globally, right? And frankly, some of the regulations for the electrical code can be very local, right? And so we really count on our partners who are utilizing our software. They're the experts in what's up to code and what's required. They can really do the appropriate design and the installation. They're effectively just using our software to manage that EV charging once it's installed.
Okay, makes sense. Yes, that's what I thought too. I mean, again, I think we're primarily talking about the management system, right? Not the electrical connection. All right, Chris is asking also for you, Marina, how frequently do Vivo customers actually use the boost option?
Yeah, so that's a great question. You know, when we first designed the system and launched it, we actually thought that the boost functionality would be used pretty often. You know, because the most common question that I get when I do these presentations is, but what would happen if everyone tries to hit the boost button at once? And so I can tell you that's never happened. Okay, we've never had everyone at the site try to hit the boost button at once. What we tend to see most often is when people first get the system, especially if they are relatively new EV drivers, and you know they plug in their car and like nothing happens, right? The app says it's waiting to charge and charging will start at this time. And then if they're not familiar with how the system works, they'll start pushing the boost button. No, okay, now it's charging. Okay, they feel good. Now everything is fine. But once they understand how the system works, what we find is that it's actually very rare. I mean, we're talking about less than 5% of all the transactions and all the charging sessions are actually boost transactions. And I think this is very much a function of, you know, just if there are behavioral economists in the audience, default settings play a very large role in that. But there's also just if people want to discuss this more, we actually have done some work with a PhD researcher who's analyzed, you know, the tens of thousands of charging sessions in environments like Israel, where there are no incentives for EV charging. So the only time that people are buying EV chargers is when they actually need them, because people are driving electric vehicles. So we have very high utilization rates. And that actually gives you a really good insight into how people are actually using those charging day in, day out, how often they are charging, how often are they overriding default settings, how sensitive are they to on-peak, off-peak price differentials. And we have shared this data actually with the system operator and regulator in Israel, and they found it really fascinating. So if there are any folks from utilities here who'd like to learn more about that data, please reach out to me after this.
Excellent. Next question, actually a very interesting one, you know, more from a consumer perspective. Adrian asks, if I understand correctly, I cannot trust my vehicle will be charged on time because anyone coming in and paying the premium would rob me of the capacity. So, you know, how can customers be guaranteed to have at least, you know, a minimum charge?
Yeah, so I think it's important here that a few things. One, we need to make sure that we're talking about sort of the right use cases because, you know, within our system, we support public charging, charging at multi-unit dwellings, workplace charging, fleets, destination charging, and each of those scenarios and use cases have a different kind of requirement or, you know, different approach, different ways to authenticate and so on. So maybe if I talk specifically about situations with deeded parking where, you know, there's sort of the same person charging their vehicle at that parking spot every day, one of the things that our system can do is learn driver behaviors. So over time, it knows that you typically leave for work at 6 in the morning on weekdays, but actually this other person typically leaves for work by 8 in the morning. So your car is going to need to be charged before the other person's car, right? Now, I think what the question gets to really though is that what I mentioned in the previous answer is this question of like, yes, but what if everybody is trying to boost at the same time? And as I mentioned, this very rarely happens. The other thing that we know about charging behavior is that most people don't wait until they're on empty to plug in their car, right? So basically using our system, your vehicle will still be charged by the time that you need it. You can always hit the boost button and override it if you really need to get your car charged faster. But we've never seen situations with our system that people aren't getting charged by the time that they expected. What this effectively accomplishes by having these kinds of default settings is that it brings down the cost overall for everyone, not only everyone in the building, but sort of, bigger everyone, ratepayers and so on, right? So that you don't need to build more infrastructure and have more capacity for on-peak times.
Yeah, makes sense. Makes sense. Thanks, Marina. All right. Moving on swiftly here, question for Evan. Kind of, I guess, a technical here. I hope that you already are that far in your development, but how quickly can the open road system recharge after discharge when supplied with, for example, 7 kilowatts of power input?
Okay, so I mean that's relatively easy math. I don't mind doing it in public. So if you had 20 kilowatt hours of total capacity, if you built a big stack of 6, and you had 7 kilowatt input, that's about 3 hours. Is about 20 divided by 7. So it would take about 3 hours to charge the stack again.
Yeah, makes sense. Makes sense. Along the same lines for Evan.
I should also notice, I emphasize though that what we want to do is when the stack is depleted, if you want to come charge anyway, we'll always give you whatever the outlet has, whatever the circuit is on has. So you can always fall back to level 2 as a pass through. So there's always something. But to get the level 3 burst, yeah, it'll be about 3 hours to fully charge. And then if it's partly charged, we would just mix the power together and give you some AC and some DC as a DC out.
Right. Makes sense. Makes sense. Yeah. I think the answer here is probably yes, but will the battery also perform other use cases such as load shifting, peak shaving, and so on?
Yeah, that's the intent, because it turns out like once you're going to collocate a bunch of batteries on the internet, you should also do these things. It's just a natural thing to do. So yes.
The follow-up to that, I think, for Evan, is by using a battery as the interface to the vehicle, does that simplify the bidirectional charging certifications for the inverter or the vehicle OEM? Or that could be a tricky question, I guess, after all.
That is interesting. I mean, potentially, I guess. I'm not sure. I mean, we do support bidirectional in the sense that if the vehicle wants to get the grid through us, we can do that. I mean, if that's the use case people want. I don't know if it would simplify the vehicle. I mean, it's kind of interesting because at some point, you imagine like maybe we'll just take the inverters out of the vehicles. There won't be an AC to DC stage in the vehicle at all. Because right now it's a bottleneck just for back compatibility with AC charging. If the world had a lot of DC charging out there, you could drop the inverter in vehicles entirely, and then like a lot of things just get a lot simpler electrically, cost-wise. I don't know if we're quite there, but yeah, I guess you could imagine that happening. Yeah.
Yeah, and I'm guessing here that this also circles around, of course, grid code requirements of the inverter, right? I mean, there are certain standards, that in some areas are required, like 2030.5 and so on, to adjust the grid code settings in these inverters periodically and so on. So I think it's starting to get fairly, difficult, I guess, to actually get the full certification set for the inverters. So that's maybe where the question is coming from here. Yeah. All right. Back to Marina here. How do you track charging customer satisfaction with their final SoC as they exit the charging space?
Interesting question. So I don't know that we have, so maybe this is a point I should have clarified, that in our case, our go-to-market is, and where we sit in the value chain, is that we typically don't sell the software directly to site hosts. We work with charge point operators, companies that are providing EV charging sort of turnkey services. So therefore, they are managing the installation, they are procuring the hardware, they're processing all the incentives, and then post-commissioning, they're responsible for the operations and maintenance of the EV charging. So the best way that we can track customer satisfaction is the customer satisfaction of the charge point operators who we work with, because frankly, if they would be getting a lot of complaints from their site host customers and the drivers, then they would be switching from Wevo very quickly and going to a different OCPP backend and that would be the end of it. But I can tell you that as it stands, we have a 99% retention rate, and we have a 98% customer satisfaction score. So those are numbers that we're very proud of. That is not something that you will often find in any kind of industry, let alone something like the EV space. So I can tell you that, you know, drivers, charge point operators alike have been extremely happy with our product.
Perfect. Oh, actually, the next question also for you, and it's not for me, surprisingly, but how do you leverage OpenADR within your solution?
So I appreciate the question. To be perfectly honest, it really is early days for us when it comes to OpenADR. So I think we've just very recently joined the OpenADR Alliance, and we're still finalizing the implementation of the protocol. So I have, you know, certainly big hopes that once everything is finalized and ready to go, we'll be able to start using that to get even more value from flexibility from EV charging.
Makes sense. Makes sense. The next one here, I'm trying to find where I was. For Evan here, I think we have time for like one or two more. We have a whole bunch here. So the next one here, OpenRoad. How will you manage expectations and for a spot that may experience back-to-back charging customers?
So couple of answers. If you have these things in a spot where there's sort of higher than usual traffic, you can also dial down the output of the power and essentially sort of sell battery power mixed with AC power for some longer period of time at a lower speed. But you know, in general, you can always get L2, like I said, if you're on an L2 circuit. So there's always something coming out. So worst case, it's the charger you could have put there anyway. Best case, you get that plus a bunch of additional power boost. But I mean, in general, there's kind of this mindset everyone's going to have to shift through to kind of make EVs work in the intermediate term here, which is that you can't, everybody in America cannot charge their EV to 100% at 7 p.m. every day. We're going to take a while to build the grid out to the point where people are comfortable with it. In the meantime, both of our companies are kind of maximizing the resources at hand to make the situation incrementally a lot better. So some of it is people's expectations are just of necessity going to change a bit, and you might not know if your car's going to be at 80% or 65% in the morning, but it's going to be, we'll all do our best to make it good enough. So yeah, there are trade-offs, but in general, our selling point to a site operator is going to be, it's always at least L2 on an L2 circuit, best case it's L3 or some level of L3. So there's always something and hopefully more.
Okay, sounds good. So I'm looking at my clock here. I guess one minute left. Whoops, I just switched to a different view here. Then we'll just grab the last one here in a row. That's for Marina again. Do you have an extra fee for using the boost button? You might have said that, but weren't sure anymore.
Great question. So yeah, typically there's a different fee for standard charging versus boost charging. What that fee is and how you define it, that's up to the charge point operator or the site host. So we have a really robust rate engine where you can define how you want to set your pricing for the EV charging. If you want transaction fees and connection fees and all, you know, boost versus standard, if you want to do cost plus, all kinds of different scenarios where we can support through that rate engine. And so one of those will allow either the site host or the charge point operator to define what they want that pricing to be for standard charging versus boost charging.
Super, excellent. Thank you so much. I see a whole bunch of other questions here from John Manny and Alice Lapierre and so on. Feel free to shoot me an email. In particular, if you had a question also for OpenADR, and we have you know, to put something on the calendar really to discuss that. So Rolf at openadr.org, as you can see here. Thank you again so much, Marina and Evan. This was really, really interesting. So thanks for being on, and I'm sure we'll talk soon again.
Thank you very much.
Yep.
All right, thank you everybody for joining today, and we'll see you soon on another webinar.